Good morning, parents, teachers, and learners. It is nice to see you again on our last session of our Mathematics 9 Valenzuela Live. Before we begin, make sure that your pen, paper, and scientific calculators are with you for solving and taking notes purposes. Also, open your ADM or modules on page 17 for our topic that will deal on problems involving oblique triangles. After the discussions made in the previous video lessons about oblique triangles and the laws of sines and cosines, now we will apply those concepts and skills as we solve problems involving oblique triangles. Let us be guided by the learning goal or objective for today. At the end of the discussion, you should be able to solve problems involving oblique triangles. Just a simple reminder, make sure that your scientific calculators are in degree mode for us to solve the problems that will be presented properly and correctly. Also, I hope that you can still remember the formulas about the law of sines and the law of cosines. At this point, let us go back to our ancestors' time. Meet my Mathenic family. I will introduce to you some of the famous and brilliant mathematicians with their unique and outstanding works. Now, let us meet them one by one. We will do it using an activity entitled Flip the Card. In this activity, in order to reveal the mathematician, we need to study the figures and statements that will be presented in each item. Then, we need to classify the following oblique triangles, whether each can be solved using the law of sines or the law of cosines. You will be given 10 seconds to decide on your answer. Put them in the comment section. Here are the cards that we need to flip. Who are the mathematicians that we are to see? Are you ready to meet them? That's great! Let us start with the first item and flip the first card. Item number 1. Law of sines or law of cosines. Which between the two can be used to solve for the length of the missing side x in the given figure? Look at the figure closely. Your timer starts now. Did you answer law of cosines? That's correct. Considering the given information in the oblique triangle, two sides and an included angle are present in the figure, which follow SAS pattern. Hence, we will use the law of cosines to solve for the measure of the missing side. Who is the mathematician that we are to unfold? He is none other than Archimedes. Archimedes is known as the father of mathematics. He is a Greek mathematician, a physicist, engineer, inventor, and astronomer. His notable work dealt on the discovery of the relation between the surface and volume of the sphere and its circumscribing cylinder, and of course, our irrational number pi. In addition, he is well known for his hydrostatic principle, known as the Archimedes principle. Let us continue to item number 2. Law of sines or law of cosines. Which between the two can be used to solve for the length of the missing sides of the given oblique triangle? We are given with 60 degrees and 46 degrees angles and a side that measures 20 inches. 10 seconds begins now. If you answered law of sines, then you are correct. It seems that you can still remember the patterns under the law of sines and the law of cosines. Note that we are given with two angles and an included side or follows the pattern ASA. Hence, we use the law of sines to solve for the missing sides x and y of the given oblique triangle. Let us find out who is the next mathematician. I know that you already encountered him. He is Euclid of Alexandria, the father of geometry. He is a Greek mathematician who is most prominent mathematician of Greco-Roman antiquity, best known for his geometry book known as The Elements. It includes number theory, planar, and solid geometry. Item number 3 goes like this. In a forest, base camps are strategically built to secure the endangered species that are living there, as shown in the figure. Which between the law of sines or the law of cosines can be used to determine the distance between the two camps? What do you think is the answer? 10 seconds starts now. If you answered law of sines, that's incredible. If you can see, two sides and a non-included angle are given in the oblique triangle, following SSA pattern. Using the law of sines, ambiguous case to be specific, the missing side can be solved. Let us reveal what is in the third card by flipping it. Do you know who is this mathematician? He is Al-Khwarizmi, the father of algebra. He is a Muslim mathematician and an astronomer whose major works introduced Hindu-Arabic numerals and the concept of algebra into European mathematics. He has lots of significant works in the field of algebra, most especially the systematic solving of quadratic equations by completing the square. Item number 4 is given by a triangular garden in which a side is adjacent to a wall of a house will be constructed. If the sides of the garden are 30 feet, 36 feet, and 60 feet, which between the law of sines or law of cosines will be used to find the angles between the sides of the triangular garden. Analyze and draw the figure in your scratch papers. 10 seconds on the clock, go! If you answered law of cosines, that's magnificent. The three sides of the triangle are given, following the SSS pattern. Hence, we can solve for the unknown measures of angles using the law of cosines. The next mathematician is a woman. Not all great mathematicians are men. We also have great mathematicians who are women. One of them is Sophie Germain, a revolutionary mathematician. She is a French mathematician, a physicist, and a philosopher. She was known because of her work about the number theory that contributed to Fermat's last theorem and the elastic theory. I hope that you are still interested in knowing some of the great mathematicians known in our history. Let us have the last item. Item number 5. The standing point of a Boy Scout is 30 meters away from the base of the flagpole. If he makes a 65-degree angle with the ground, which between the law of sines or the law of cosines will be used to determine the height of the flagpole? Sketch the illustration that represents the problem before you decide for your answers. 10 seconds, go! This problem can be solved using law of sines. You did very well in our previous lessons. To show the illustration, we are given with two objects, the Boy Scout and the flagpole. The Boy Scout's standing point is 30 meters away from the base of the flagpole. It makes a 65-degree angle with the ground. Since the flagpole is perpendicular to the ground, it forms a right angle that measures 90 degrees. Analyzing it further, two angles and an included side are given following ASA pattern. Hence, we can compute for the height of the flagpole using the law of sines. We should also remember that right triangles can be solved by either law of sines or law of cosines, depending on the given information aside from the Pythagorean theorem and the trigonometric ratios. Who will be the last mathematician that we are to discover? He is none other than Jamshid al-Kashi. He is a Persian mathematician and an astronomer that provided the first explicit statement of the law of cosines in a form suitable for triangulation. He provided an accurate trigonometric tables and expressed the theorem in a form suitable for modern usage. Here are some of the famous mathematicians of all times. Meet my mathenic family. Are you aiming to be one of them? Who knows? You might be one of them someday. One of the Filipino mathematicians that every Filipino will be proud of. Before we proceed to the topic that will be discussed for today, let us recall when to use law of sines and law of cosines. Which of the following patterns can be used in solving oblique triangles using the law of sines? How about the law of cosines? Oblique triangles can be solved using the law of sines if the given information follow the patterns ASA pattern, AAS or SAA pattern, and SSA pattern known as the ambiguous case. On the other hand, oblique triangles can be solved using the law of cosines if the given information follow the patterns SSS pattern and SAS pattern. Now that we have summed up when to use those two laws, we are ready to solve problems involving oblique triangles. Mathematics has a vast application in real-life scenario. Triangles, which is the focus of trigonometry, had played a vital role in every situation that we encountered, starting from geometry to problems that deals with right triangle trigonometry to oblique triangles. The concept of triangles is used in building trusses in bridges, which is identified to hold the structure in the most stable manner. In the aspect of navigation and considering the shortest route or the displacement between routes. Others are the triangle of life, the Bermuda and Romblon triangles, and many more. But how do we solve for the unknown lengths or measurement of angles of oblique triangles? How is it possible to apply oblique triangles in real-life situations? Is it really applicable and visible in real-life encounters? Let us find out in our discussion. Just like what we did and followed in solving word problems in the previous lessons, the same steps will be considered to make our solutions organized to come up with the correct answers, especially in dealing with oblique triangles. So after reading and analyzing the problem, step number 1, we need to identify the given information and illustrate. Step number 2, determine the formula to be used. In this case, which one? Is it the law of sines or the law of cosines? Step number 3, solve for the unknown in the problem. And then the last one, state the final answer. Let us start with problem number 1. You decided to go for fishing in Tagalog Fishing Village, where it is known for its products like tilapia and bangus. You used a straight improvised 4-foot fishing rod. So while waiting, you stop the fishing rod, which forms an angle 65 degree with the ground. If the fishing rod where it is stopped is 20 feet away from the bait, how long is the string that is attached from the end of the fishing rod? Round the answer to the nearest hundredths. The given information that we can use are the length of the straight improvised fishing rod, the angle formed with the ground, and the distance from the fishing rod where it is stuck to the bait. Let us use these facts as we illustrate the problem. The straight improvised fishing rod is 4 feet long. It formed a 65-degree angle with the ground. The distance from the point where it is stuck to the bait measures 20 feet. We are asked to find the length of the string that is attached at the end of the fishing rod. If you can see, an oblique triangle is formed. Let us use this figure as we determine the formula to be used. Based on the given information found and labeled in the oblique triangle, we have two sides and an included angle following SAS pattern. Hence, we will use the law of cosines to solve for the length of the unknown side. Let us name the given triangle as ABC. Next, let us represent the unknown side as A, since it is the side opposite angle A, and the remaining sides as side B and side C. Since we are to find the length of A, we use one of the formulas provided in the law of cosines. Which one do you think will help us solve for the unknown length of A? Fantastic! We use the formula A squared is equal to B squared plus C squared minus 2BC times cosine A. Let us continue our solution. Substitute the given information to the formula. That's why we obtained A squared is equal to the square of 20 feet plus the square of 4 feet minus 2 times 20 feet times 4 feet times cosine 65 degrees. Simplifying this further, we now have the equation A squared is equal to 400 square feet plus 16 square feet minus 160 square feet times cosine 65 degrees. Using your scientific calculators, A squared is equal to 348.38107812 followed by ellipsis dots square feet. We need to extract the square roots of both sides of the equation and take its positive root. Hence, A is approximately 18.66497 followed by ellipsis dot feet. The problem asked us to round our answer to the nearest hundredths. So what will be the value of A? That's correct. A is equal to 18 and 66 feet. To answer the problem, the string that is attached at the end of the fishing rod is 18 and 66 feet long, rounded off to the nearest hundredths. In the problem, can you still remember where we went to catch fish? It is found in one of the barangays in Valenzuela City, one of the places developed for tourism in the Gateway of the North. This is in Tagalog. Tagalog is bounded by Pola River in the west, Maykawayan River in the north, and Caloong River in the east. One of the attractions in Barangay Tagalog, Valenzuela City is the Tagalog Fishing Village. The 101-hectare barangay has 22 ponds with an average depth of 9 feet and was declared as the City Ecotourism Zone in 2016. Tagalog Fishing Village was also the first fishing village in the city of Valenzuela that was formally inaugurated on February 15, 2020. The Valenzuela city's best-kept secret lies beside a 1,300-meter boardwalk with light posts and fence adorned with statues of fish that can be caught there. It was constructed to preserve the fishing site. Let us have another problem. Problem number 2. During every year's Math Festival, Math Trail is one of the most awaited parts of the whole week celebration. It involves a group of students and a teacher. It is composed of learning stations where a task is needed to be accomplished before proceeding to the next level. Last school year, the stations were named as algebra, geometry, and trigonometry. Algebra is 24 feet away from geometry. The angle between the line formed by algebra to geometry and algebra to trigonometry is 36 degrees. And the angle between the line formed by geometry to algebra and geometry to trigonometry is 100 degrees. How far is the station geometry to the station trigonometry? Round the answer to the nearest hundreds. The given information that we can use in the problem are the distance from station algebra to station geometry and the angles formed between the lines. Note that we have two angles given. Let us use this given information to illustrate the problem. We are given with 3 learning stations. So we have stations algebra, geometry, and trigonometry. It is stated in the problem that station algebra is 24 feet away from station geometry. Next, the angle between the line formed by algebra to geometry and algebra to trigonometry is 36 degrees. And lastly, the angle between the lines formed between geometry to algebra and geometry to trigonometry measures 100 degrees. The figure shows an oblique triangle, an obtuse triangle to be specific. How are we going to solve for the distance between geometry and trigonometry? Let us answer that by determining the formula to be used. Using the oblique triangle form, there are 2 angles and an included side that are given following ASA pattern. With this, we use the law of sines to find the length of the unknown side. Let us name the triangle as AGT using the first letters of every station. Next, we represent the unknown side as A since it is the side opposite one of the given angles, angle A. Then, we represent the given side as T since it is the side opposite angle T. Relating the 2 sides A and T and the 2 angles angle A and angle T, we use the derived form of the sine formula A over sine of angle A is equal to T over sine of angle T. Before we use the formula, let us solve for the measure of angle T. Since it is a value that is needed in the formula that we are to use. To solve for the measure of angle T, we apply the theorem stating that the sum of the interior angles of a triangle is equal to 180 degrees. Substituting the values to the equation, we obtain 36 plus 100 plus the measure of angle T is equal to 180. And if we continue to simplify, we will obtain the measure of angle T, which is 44 degrees. Now, we are ready to solve for the measure of the side, which is A, using the formula A over sine of angle A is equal to T over sine of angle T. Substitute the given information to the formula, we will obtain A over sine 36 degrees is equal to 24 feet divided by sine 44 degrees. To get the value of A, we need to multiply both sides of the equation by sine 36 degrees. Cancel sine 36 degrees. The solution will be A is equal to 24 feet times sine 36 degrees all over sine 44 degrees. Using our scientific calculators, it will result to A is approximately 20.3076 followed by ellipsis dots feet. Note that in the problem, we should round off the answer to the nearest hundreds. Hence, A is now equal to 20 and 31 hundredths feet. So, to answer the question in the problem, the distance between station geometry and station trigonometry is 20 and 31 hundredths feet rounded off to the nearest hundredths. During the face-to-face classes, the well-known MTOP or MMC is one of the most awaited events by math enthusiasts. In this event, students compete by answering math questions in written and oral form and individual and group category. But did you know that there is an International Day allotted for mathematics? The International Day of Mathematics, or IDM, is a worldwide celebration each year on March 14 at all countries. So all countries are invited to participate through the activities for both students and the general public in schools, museums, libraries, and other spaces. Maybe it was dated March 14 to commemorate with the value of pi to the nearest hundredths, which is 3.14. Now, you know. Let us have a challenging question provided by problem number 3. Using a clinometer, JC measures the angle of elevation of the peak of a chocolate hill as 35 degrees on a straight, level path. Sarah, who is 40 meters away from JC, measures the angle of elevation of the same hill as 42 degrees. The question is, how high is the hill? The given information are the angle of elevation from JC to the peak of the hill, Sarah's distance from JC, and the angle of elevation from Sarah to the peak of the same hill. Let us use the given information to illustrate the problem. In the problem, it is stated that JC's angle of elevation of the peak of the hill is 35 degrees, while Sarah's angle of elevation of the same hill is 42 degrees. We also need to note that Sarah is 40 meters away from JC. Now, we are asked to find the height of the hill. To find the answer to the problem, we need to determine the formula that we will use. Let us consider the triangles that are formed. Let us make a plan on how to solve the problem. The first plan is using the oblique triangle described by the orange triangle. We use the supplement of 42 degrees to find the adjacent angle that is found in the oblique triangle. Next, we will solve for the remaining angle to complete the angles of the given oblique triangle. Furthermore, we need to compute for the distance from Sarah to the peak of the hill, which is represented by the variable x. To solve for the value of x, we will use the sine law. After getting the value of x, we go to step number 2 of the plan. So using the right triangle formed described by the blue triangle in the figure, we use the trigonometric ratio and solve for the height of the hill. Now, let us go over and do the plan. Use the oblique triangle described by the orange triangle and name it as JSP. Using the linear pair postulate, we can say that the supplement of 42 degrees is 138 degrees. This will serve as the measure of the obtuse angle in our oblique triangle. Next, we need to find the measure of angle P. Other way of doing this is to get the sum of the given angles, then subtract it from 180 degrees. We will obtain measure of angle P is equal to 180 minus the sum of 35 and 138. Simplifying this equation, it will result to the measure of angle P, which is equal to 7 degrees. Let us name the side that measures 40 meters as P, as we are to use the law of sines. Using the law of sines, we relate the given side and the unknown side, and the two angles J and P. By that, we will use the derived form of sine law based on our given triangle as J over sine of angle J is equal to P over sine of angle P. We should take note that J and P are the sides of our oblique triangle. Also, take note that side J is just equivalent to X, as represented in the figure. So we now have X over sine of angle J is equal to P over sine of angle P. Substituting the values to the formula, we obtain X over sine 35 degrees is equal to 40 meters over sine of 7 degrees. To get the value of X, we need to multiply both sides of the equation by sine 35 degrees. Cancel sine 35 degrees. The equation will be X is equal to 40 meters times sine 35 degrees all over sine 7 degrees. Using your scientific calculators, we obtained X is equal to 188.26 meters or 188 and 26 hundredths meters to the nearest hundredths. Let us now continue our solution and follow the next step. Step number 2. Let us consider the right triangle described by the blue triangle here. We computed for the distance of Sarah to the peak of the hill, or the variable x, as 188 and 26 hundredths meters. At this point, let us use the trigonometric ratio to solve for the height of the hill. Solve for the height of the hill. Let us represent the height of the hill or the missing side of the right triangle as h. Note that the reference angle is 42 degrees. With respect to the reference angle, h is the opposite side. The side that has the measure 188 and 26 hundredths meters is the hypotenuse of our right triangle. What trigonometric ratio should we use to relate the opposite side and the hypotenuse of the right triangle given with the reference angle 42 degrees? Precisely, we will use the sine ratio. Substituting the given values, we will now obtain sine 42 degrees is equal to h over 188 and 26 hundredths meters. To find the value of h, we will multiply both sides of the equation by 188 and 26 hundredths meters. Cancel 188 and 26 hundredths meters. It will yield to 188 and 26 hundredths meters times sine 42 degrees is equal to h. Using our scientific calculators and applying the symmetric property, we will obtain the approximate value of 125.970528 followed by ellipsis dots meters. The problem asks to round the answer to the nearest hundreds. Hence, h is now equal to 125 and 97 hundredths meters. Finally, to answer the question in the problem, the hill is 125 and 97 hundredths meters high to the nearest hundreds. We talked about chocolate hills. Where can you find this fascinating place? That's right. These hills can be found in Bohol, Philippines. Let me share to you these bits of information about chocolate hills. The chocolate hills in Bohol, located at Central Visayas, are conical-shaped mountains or haycock hills. The chocolate hills are famous worldwide. The hills are covered in green grass almost all year round. However, in the dry seasons, this grass turns to a chocolate brown color, hence they are called chocolate hills. The height of the hill ranges from 120 feet to 420 feet, or approximately 30 to 140 meters, which are spread across the towns of Sagbayan, Carmen, and Batuan in Bohol. There are folklores on the origin of the chocolate hills. One is the battle of two giants hurling rocks at each other that formed the chocolate hills. Another is about numbers. A giant named Arogo who fell in love with a girl named Aloya. The girl was a mortal, and when she died, the giant was heartbroken. He shed bitter tears in her memory. Wherever these tears fell, a mountain was formed. Let us proceed to the last problem, problem number 4. Two sides of a triangular garden measure 25 meters and 30 meters. Find the area of the garden if the included angle of the two given sides is 60 degrees. Round the answer to the nearest whole number or nearest meter. The information that we can use are the measures of the two sides and the measure of the included angle. Let us use these to form our illustration. Let us consider the top view of our garden. In the problem, it is stated that a side of a triangular garden measures 30 meters, while the other side measures 25 meters. The included angle between those given sides is 60 degrees. We are asked to find the area of the given triangle. Using the facts from the problem and its illustration, let us proceed to determining the formula to be used. If you can remember, the triangle has no given altitude or height. Hence, we cannot use the formula the area of the triangle is equal to 1/2 base times height. There is another formula that we can use for this problem, and that is the area of the triangle is 1/2 the product of any two given sides of the triangle and the sine of the included angle. It can be expressed as the area of the triangle is equal to 1/2 A times B times sine C, where A and B are the sides of the triangle and C is the included angle. At this point, let us solve for the area. Solving for the area using the given figure and the given information, let us fill in the blank in the given formula. The two sides are 25 and 30 meters. And the included angle is 60 degrees. Using your scientific calculators, the area will be approximately 324 and 76 hundredths meters. Remember that we are only asked for an answer to the nearest meter or whole number. Hence, the area of the triangle is 325 square meters. To formally answer the question, The area of the triangle is 325 square meters to the nearest whole number or meter. Do you know other formula in solving for the area of a triangle aside from what were mentioned a while ago? Did you know that we have what we so-called as the Heron's formula? This is used to solve for the area of a triangle given its three sides. So we let A, B, and C be the lengths of the sides of any triangle. We let S be the semi-perimeter. The semi-perimeter can be computed by getting the sum of the sides and divide it by 2. After getting the semi-perimeter, the Heron's formula can be used provided by A is equal to the square root of S times the binomial S minus A times the binomial S minus B times the binomial S minus C. The formula was credited to Heron of Alexandria. At this point, I hope that you find mathematics an interesting subject because of its beauty and application beyond its complexity. Let us sum up today's discussion. In solving problems involving oblique triangles, we follow the steps to make our solutions organized to come up with the correct answers. So after reading and analyzing the problem, here are the steps. Step number 1, identify the given information and illustrate. Step number 2, determine the formula to be used. Step number 3, solve for the unknown in the problem. And then the last one, state the final answer. If there are topics and ideas that seem to be unclear and need to be verified, you may ask your respective math teachers during your follow-up discussion. For your last home learning task for the school year, on your ADM, answer Keep Trying numbers 1 to 4, page 20, about solving problems involving oblique triangles. Congratulations! You completed the journey of studying Mathematics 9. The end of this chapter will definitely open a new, broader, and more challenging chapter of mathematics next school year. Your hard work, dedication, and perseverance during the Valenzuela live sessions and follow-up discussions will surely have its sweetest fruit that you will harvest soon. This made us prove that the struggles and dilemma brought by the pandemic will never put us in our knees. It made us better persons by looking at the silver lining in every situation. This is Mr. Jude Carlo L. Pilapil, your live streaming teacher in Mathematics 9, signing off. See you again next time in Valenzuela Live. Stay safe, good day, and God bless.